Hello, everyone. We are back with another quant slash financial engineering podcast. And with me today, I have Dr. Neal Snow. Dr. Snow is a faculty at the Lehigh University. And I'm going to let Neal introduce himself in a little more detail. But we're here today to discuss a recent document, a research paper that he put together with other people, and Paul Brockman, which actually is also a faculty at Lehigh, having to do with commonality in liquidity. And I'll let Professor Snow go into great detail as to what this is and why this is important and what he found and a bit of history. But first, let's start by having you tell us a little bit about yourself so we could frame you within the Lehigh and within the research environment.
Sure. Well, thank you for having me on. First off, it's a pleasure to be here and be able to discuss the work. And so a little bit of background. I've been at Lehigh starting at 2015. Came straight out of my PhD program at University of South Florida. There I received a PhD in accounting and with a minor in information systems. And I've basically done accounting all the way through for both my undergraduate and my master's. Before I got my PhD, I worked at Goldman Sachs for 3 years and Deloitte & Touche for 1 before that. So I have kind of background on both sides of, you could say, academia and industry. And my teaching has, I taught MBA 402, which is like financial statement analysis and valuation for the last 4 years. Co-taught that with Sam Weaver here at Lehigh. And then I've taught the data science for accountants class for the last 5. Started that in 2016 and continue to teach that. And then teach accounting information systems starting in spring.
Which has a lot of Python and language processing and all that good stuff, right?
Right. So my machine learning, data science for accountants really is pretty hardcore data science. We teach Python, we go through pandas and use scikit-learn for our machine learning software, all in Jupyter notebooks and covering what's kind of standard fare at this point. Predicting continuous variables with regression and classification topics, and then have done multiple final projects from anomaly detection using semi-supervised methods to network analysis on blockchain to network analysis on Twitter, and then doing some NLP with topic analysis. Really kind of varies on that final project on what students.
Topics for future podcasts, definitely on NLP. I want to talk to you more about that. But so let's address this article, this research paper, peer reviewed by on this commonality in liquidity. So frame this for us a little bit as to what's the history behind it, and how did you go about it, and what did you find? So what is it all about?
Okay, well, those are a lot of questions. So this paper came out of teaching in the MBA program and that financial statement analysis about, and I had a class on, just one class on peers and how do you make comparisons, right? Because your peer group really matters in valuations, right? If you're choosing the wrong peer, it doesn't matter what else happens, right? If your competitor's off, then you're going to be blindsided. And so I wanted to introduce some different ways that people had looked at peer groups. And one of them that had recently came about was this Journal of Financial Economics from Lima and Wang on search-based peers. And these search-based peers they looked at the EDGAR log file. So EDGAR is the repository for all publicly traded firms that have filed with the SEC. And it's on this file. And through Freedom of Information Acts, people were able to get the log files. So everybody who hit the database and requested an SEC filing, so 10Ks, 10Qs, 8Ks, Def 14As, S1s, things like that. And then when we look at search-based peers, it's a co-search fraction. We look at fundamental documents, so 10Ks, 10Qs, 8Ks, Def 14As, and S1s. And so we see who accesses a firm's particular filing on a particular day. And then we look at who do they look at a firm's filing, a different firm's filing, who do they look at next, right? So, for example, you could go and search Apple's 10K. But then after you're done looking through the 10K, you could go then look at Microsoft's 10K. And this would be considered a co-search in our paper. And we take all of these co-searches for every day for all IP addresses that searched on the SEC less than 50 times a day. We figured if somebody's hitting the SEC site more than 50 times, they're probably not a real person. They're probably a bot. So we eliminate those. And then we aggregate all of these co-searches together for all of the firms that file with the SEC and add them up for an entire year, so fiscal year, so January 1 to December 31st. And for each of those co-searches, then we divide it by the total number of co-searches for the firm. And this gives us a co-search fraction. And those that have the highest fraction are then considered search-based peers. And in our paper, we look at the top 5 peers for that year. We also look at the top 10, but the results that are reported in the paper are for the top 5 peers. And Lima and Wang, they find that this search fraction follows a power law. So primarily the first 3 have the highest, and then it drops off quite precipitously after that, which is why we look at the top 5, because we're really looking beyond what we need to capture that. So the interesting thing about search-based peers is that they're not as sticky as industry classifications. So, because industry classifications, like your standard industrial classification, they get applied once when the firm goes public, and then they don't get updated again. And so if you have a firm like Amazon, they got classified as an internet commerce business 20 years ago. But they make most of their money now in cloud services. So that SIC code, right, isn't very applicable, right? If you wanted to see who is Amazon's competitors, it's not just Walmart or Target who are more in the retail space. It's, a whole host of other firms. So if you go by the SEC firm, then by the SIC code, you lose dynamic, you don't have it. It's not dynamic. It doesn't update as the firm updates and its business strategy and products change. And so looking at these search-based peers and what it reveals, really what these searches kind of reveal to us, because it's not like investors are publicly disclosing this, right? It's there stuck in the log files. Then they're able to reveal these economic relationships that we wouldn't otherwise see. And so we took that and then wanted to see, well, how does this influence market factors? How does this influence, which is really kind of like market microstructure of what commonality and liquidity is. And so to look at commonality and liquidity, we look at the change in really two big liquidity factors, which is bid-ask spread and depth or volume. What's the number of shares that are being traded? And we add this into an equation that Chorty et al. Came back up with in 2000 that doesn't make for a good predictive model because it takes into account the change in the market, overall market, for that day. And then we look at it for the change of the market last year. And then we look at the change of the market going forward. So we look at T, we look at T minus 1, and we look at T plus 1. And so for a predictive model, it's rubbish, right? Because it's doing look ahead. But from an explanatory model, it works quite well.
So you're basically saying that depending on what the investors are looking in within the EDGAR's SEC filings, it has an impact, or there's some sort of a correlation with the stock liquidity as defined by the the volume and the bid and ask.
Yeah. So when we add in the three variables, and we do this on a by firm basis, we look at by firm, by day, and that change, then we find that the change in a firm's search-based peers, their top 5 search-based peers, their change of liquidity explains as much, and then sometimes even more, than their industry classification does. So how these search-based peers move is then explains in the range between 9 and 12% of R squared of this model. So not as much as market, obviously how the market moves has a large effect of what a firm's going to do.
Mm-hmm.
But how these search-based peers move explains more than industry.
Because your conclusions that retail investors are responsible for roughly 85% of the EDGAR searches that generate SBP, which is basically your search-based.
Yeah. So first we just wanted to see, well, do these search-based peers matter, right? Do they explain any changes in the firm's bid-ask spread and volume? And first off, that's the first thing we do in the paper, and we say, yep, yes, they do. But then we're like, okay, so who's driving these search-based peers, right? And which one is it? So after I had all of the EDGAR file logs, then I went through and I demasked the IP addresses. So this was a lengthy data collection process where I hit all the internet registries and got their IP addresses, and then broke them up by internet service providers are your retail investors, as we classified them. And then banks actually own large swaths of IP addresses. So Goldman Sachs has IP addresses, JP Morgan, Citi, you name it, they own IP addresses. And so we can say, so I don't know exactly who in those firms was searching, but I know that somebody from Goldman Sachs looked at, this firm and performed this co-search fraction on this particular date, this particular time, right? From the EDGAR file logs. And so then we break them up into institutional, like Goldman Sachs and whatnot, search-based peers. And then we look at retail search-based peers, thinking, well, maybe retail investors, maybe they have different peer groups than institutional. And so maybe those don't work. Maybe those don't influence as much as compared to institutional or industry or whatever. And what we find is that those institutional search-based peers and those retail search-based peers explain about the same amount. And so this was significant in that at least the academic literature were able to add that retail investors are a determinant of liquidity in the market, where before it wasn't as clear. They really kind of thought that it was primarily institutions that were driving it, and that retail didn't have as much. But our sample goes back to beginning of 2003 up through June 30th of 2017. And so I think that's a pretty good sample to show that retail investors had some influence.
So I guess your idea is that the more if you institutions like Goldman, 50 times a day they're looking at a bunch of names every day. You're thinking that the more they hit those names, or the way they hit them, means that they're going to take action on them some fashion. And I guess the more actions they have, you start to reduce that bid and ask. There's more liquidity in a stock, and this is important
so
because
we look at our firms that are searched together. We see that they get traded together, and then their liquidity moves together. So firms that get searched together have liquidity together, and that is robust against industries, against institutions searching for them, or retail investors searching for them, for whether or not whether they're mentioned in the same news articles or not, and across 3 different sample sizes, right? Regardless of, this is for firms that get traded, all firms, right? Some that get traded less than 50% of the time versus those that that's our internet appendix, which is like 80 pages long. We look at all these different portfolios and to see what it comes out, and it's consistent for across all of these portfolios, that firms that get searched together, their liquidity moves together.
So how can this be used ultimately? I guess if you were to create a database of some sort, or right, and you could start planning stock movement ahead of that, or you think that it would impact? Because you're not trying to predict the movement of the stock. You're just talking about the liquidity, right? How much liquidity there is in.
Yeah, it's what we look here is bid-ask spread and volume. But if that's part of your trading strategy, right? Then
Mm.
then you could generate that. We don't get into it. We
Yeah.
do get into trading strategies and what's possible there. Li Mon Wang, which is a 2015 Journal of Financial Economics paper, talks talks some about that, but that wasn't the focus of our paper.
And what's next after this? I mean, you're going to dive more into it, or is there something else?
So afterwards, kind of the one thing that we're looking at right now is, I'd say kind of like an obvious follow-up is like, what are the determinants of search-based peers, right? What are the factors that influence institutions searching firms together or retail investors searching firms together? And because preliminary analysis shows that these search-based peers, they're not the same peers year over year. You may have the same top peer, like it's pretty consistent. Apple's top search-based peer is Microsoft over 15 years, right? And I've run this in like my MBA classes, in class, so running on Google Colab's notebook so people can just kind of search at it. Walmart is pretty consistently the top search-based peer of Costco. But where it gets interesting is those second or third or fourth or fifth search-based peers. And so those are pretty dynamic, and those change. And so we're looking at factors at how those change. We've done a lot of rolling calculations to look at pinpoint where in the year this happens, what events, look at it, and we're still in the analysis stage. We really didn't kick it off until this paper kind of made it through everything.
Okay.
With review of finance. So that'll be next. And I used this measure of just internet EDGAR searches in a number of other papers to see what happens.
Looking forward to what the answer is. So I wanted to thank you for this quick introduction in terms of your research paper. It gives food for thoughts. That's for sure. And hopefully we see you very soon in another podcast.
Yeah, hopefully so. If people come to it, I'll share the SSRN link.
I will definitely put that on the
review of finance paper has the supplemental links. We didn't put that on the SSRN. It just makes for, it was already a long paper, so adding on 80 pages of supplemental analysis, we didn't put on SSRN.
Great. Neal, thank you very much for your time.
Yeah, anytime. Happy to talk anytime.
Thank you very much.